GCE O Level Mathematics, Lecture 3, Square Roots and Cube Roots. Hello everyone, I'm Dennis. This video is brought to you by Ace with Dennis. Now, learning can be smart, not hard. Don't forget to subscribe and press the bell notification button to stop missing out free lessons from me. In this video, we are going to learn to understand the concept of square numbers, cube numbers, square root, and cube root of a number. To recognize perfect squares and perfect cubes. To understand the rules of squares and cubes. Finally, to solve HCF and LCM problems involving square numbers, cube numbers, square roots, and cube roots. Square roots. What is square roots? Let's look at this case. If 2 square equals 2 times 2 equals 4, then square root of 4 equals 2. So this is how we apply square roots. Here are a list of frequently used perfect squares. So 1 square equals 1, 2 square equals 4, 3 square equals 9, 4 square equals 16, 5 square equals 25, 6 square equals 36, 7 square equals 49, 8 square equals 64, 9 square equals 81, and 10 square equals 100. Next, the next 10 perfect squares will be 11 square equals 121, 12 square equals 144, 13 square equals 169, 14 square equals 196, 15 square equals 225, 16 square equals 256, 17 square equals 289, 18 square equals 324, 19 square equals 361, and 20 square equals 400. Maybe you tell me that you don't have to memorize these numbers as you can use calculator to find for you. But I would highly recommend you to at least recognize these perfect squares because these perfect squares will appear in the question, but they won't tell you that they are perfect squares. So when you look at these numbers, you can consider about using the square numbers and change it back to the square root value to solve the question. Okay, now let's look at this example. Without using calculator, find square root of 3136. Here's the solution. We need to use prime factorization to find the square root. So 3136 equals 2 to the power of 6 times 7 square. So square root of 3136 equals square root of 2 to the power of 6 times 7 square. And to remove the square root, we just need to divide the power by 2. So it becomes 2 cubed times 7 and we get 56. Next, you can try this yourself. Find square root of 2304. From here, square root of 2304, it is square root of 2 to the power 8 times 3 square, which is 2 to the power 4 times 3. Remember, the power we divide by 2 when we square it. So 8 divided by 2 we get 4. So 3 power 2, right, square the 2 divided by 2 we get 1. So 2 power 4 times 3 we get 48. Now, let's see one example of word problem related to square roots. Here is the question. The area of a square is 576 centimeters square. Find the length of the side of the square. Here is the solution. We know that the area of a square equals length multiplied by length. Therefore, it is equals length square. So, length equals square root of area, and for this case is square root of 576, which gives us square root of 2 to the power 8 times 3 square. When we square root, we can divide the power by 2, which we get 2 to the power 4 times 3. And the answer is 48 centimeters. Now you can try this example yourself. The area of a square is 1521 centimeters square. Find the length of the side of the square. You can pause the video and try to solve it yourself. So the length equals square root of area. For this case, it is square root of 1521. We write it in the index notation, which we get square root of 3 square times 13 square. Since it's a square root, we divide the power by 2, we get 3 times 13, and the answer is 39 centimeters. Cube roots. If 2 cube equals 2 times 2 times 2, which is 8, then cube root of 8 equals 2. So here are a few frequently used perfect cubes which you should recognize. 1 cube equals 1, 2 cube equals 8, 3 cube equals 27, 4 cube equals 64, 5 cube equals 125, 6 cube equals 216, 7 cube equals 343, 8 cube equals 512, 9 cube equals 729, and 10 cube equals 1000. Again here, you don't have to memorize all these numbers. All you need to do is recognize that these numbers are perfect cubes. Again, because when this number appear in the question will not tell you that they are perfect cubes. You should recognize them and consider of cube roots to solve the questions. Alright, now let's look at this example. Without using calculator, find cube root of 2744. So here's the solution. We need to use prime factorization to find the cube roots. So 2744 equals 2 cube times 7 cube. So cube root of 2744 equals cube root of 2 cube times 7 cube. And to remove the cube root, we just need to divide the power by 3. We get 2 times 7, which gives us 14. Alright, and now let's try this example yourself. Cube root and 3375. So you can take some time and do yourself. Alright, so here's the solution. Cube root of 3375 equals cube root of 3 cube times 5 cube. When we want to remove the cube root, we need to divide the power by 3, so we get 3 times 5, which gives us 15. Now let's solve word problem related to cube roots. Here's the example. The volume of a cube is 9261 centimeters cube. Find the length of the side of the cube. Here's the solution. We know that the volume of the cube is length times length times length, which is length cube. Therefore, the length of the cube is cube root of the volume, and for this case, it is cube root of 9261. 9261 is 3 cube times 7 cube. So to cube root the number, it becomes 3 times 7, which gives us 21 centimeters. Now you can try this example yourself. The volume of a cube is 5832 centimeters cube. Find the length of the side of the cube. You can try to solve it yourself. And here's the solution. The length is the cube root of the volume. For this case, it's cube root of 5832, which is cube root of 2 cube times 3 power 6. To remove the cube root, we have to divide the power by 3. Therefore, we get 2 times 3 square, and the answer is 18 centimeters. Here are some rules of square roots, cube, and cube roots to follow. 1. Square or cube of a positive number is always positive. Examples: 2 square. We know that it is equals to 2 times 2, which is 4. So the 2 is positive, then we get the answer 4. Similarly, 5 cube equals 5 times 5 times 5, which gives us 120. 25. So the 5 here is positive, therefore the result is also positive. 2. Square of a negative number is always positive. Here's an example. Negative 2 square equals negative 2 times negative 2, we get positive 4. So the negative 2 here is a negative number and the result is positive. As we know that negative multiplied by negative number, we get a positive number. Similarly, negative 10 square equals negative 10 times negative 10 equals 100. So the negative 10 here is a negative number. After we square it, we get a positive number. Next, cube of a negative number is always negative. So for example, negative 2 cube equals negative 2 times negative 2 times negative 2, we get negative 8. Notice that negative 2 times negative 2, we get a positive number, and the positive number multiplied with negative again will get a negative value. So similarly, negative 10 cube equals negative 10 times negative 10 times negative 10, and we get negative 1000. 4. Positive square root or cube root of a positive number is always positive. Here's an example. Square root of 4 equals 2. And cube root of 125 equals 5. Notice that square root and cube root is an inverse process of the squares. And the rule number 4 and rule number 1, they are related to each other. 5. Negative square root or cube root of a positive number is always negative. Here's an example. Negative of square root of 4 equals negative 2. And negative of cube root 125 equals 5. You can treat it as negative 1 times square root of 4, which you get negative 2, or negative 1 times cube root of 125, and we get negative 5. Rule number 6. Square root of a negative number is undefined. For example, square root of negative 4 is undefined. Square root of negative 25 is also undefined. As we know that even if the two negative numbers multiply together, we always get a positive. For example, negative 2 times negative 2, we get positive 4, which we have seen in the previous rule. Rule number 7. Cube root of a negative number is always negative. Here's an example. Cube root of negative 125 will give us negative 5. As we know that negative 5 cubed, we get negative 125. Similarly, cube root of negative 343 equals negative 7. As we know that negative 7 cubed, we get negative 343. Rule number 8. When a perfect square is represented in index notation, the powers of the prime factors are divisible by 2 or even number. For example, 784 equals 2 to the power 4 times 7 square. So when you square root 784, which equals square root of 2 to the power 4 times 7 square, and the result is 2 square times 7. We do this by divide the power by 2. So 4 divided by 2 we get 2, and 2 divided by 2 we get 1. And the answer is 28. Number 9. When a perfect cube is represented in index notation, the power of the prime factors are divisible by 3 or multiples of 3. Here's an example. 1728 equals 2 to the power 6 times 3 cubed. So, cube root of 1728 equals cube root of 2 to the power 6 times 3 cubed. So, since it is a perfect cube, when we cube root it, we can divide the power by 3. So 2 power 6, the 6 divided by 3, we get 2 square. 3 to the power 3 or 3 cube, we divide by 3 the power, we get 3 to the power 1. And the result is 12. After understanding all the rules that we need to follow, let's look at some examples. Here is the question. Given that 132 equals 2 square times 3 times 11 and 360 equals 2 cube times 3 square times 5, find A, the largest integer which is a factor of both 132 and 360. B, find the smallest positive integer n such that 132n is a multiple of 360. C, find the smallest integer value of k such that cube root of 360k is an integer. Here is the solution. For A, the largest integer which is a factor of both 132 and 360 is actually the HCF. So given that 132 equals 2 square times 3 times 11 and 360 equals 2 cube times 3 square times 5. So we want to find the HCF, which gives us 2 square times 3. And the answer is 12. For B, we know that 132 equals 2 square times 3 times 11. After multiply n, we get 132n should be equals to 2 cube times 3 square times 5 times 11, because this is the LCM of 132 and 360. Hence, for the n, it must be 2 times 3 times 5, because 132 we have 2 square, it must times with 2 so that we can get 2 cube. So similarly for 3, in 132 there is 1 3 here, the n must multiply with another 3 so that it can get 3 square. And then 132 there is no 5, therefore they must have a 5 in n, and we get times 5 here. For the 11, we just copy down here. Therefore, there is no 11 in n. And the result for n is 30. For C, given 360 equals to 2 cube times 3 square times 5, multiplied by k, we get 360k, and it need to be a perfect cube so that when we cube root it, we can get an integer. So the 360k, the powers must be divisible by 3. Alright, so we compare the 360 2 cube. So there is already 2 cube here, then the k, there is no 2. For 363 square, right, we still lack of 1 3, hence the k must have a 3 here. Similarly for 5, there is only power 1, it must have be 5 square so that 360k is 5 cube. Hence, the k is 75. Alright, now you can try this example yourself. Given that 300 equals 2 square times 3 times 5 square and 140 equals 2 square times 5 times 7, find the largest integer which is a factor of both 300 and 140. B, find the smallest positive integer k such that 140k is a perfect square. C, find the smallest integer value of n such that cube root of 300n is an integer. You can pause the video and try to solve it yourself. Alright, here's the solution. For A, given 300 equals 2 square times 3 times 5 square and 140 equals 2 square times 5 times 7, and we are actually want to find the HCF of 300 and 140, which gives us 2 square times 5. And the answer is 20. For B, find the smallest positive integer of k, such that 140k is a perfect square. We know that 140 equals 2 square times 5 times 7 multiplied by k, we get 140k, we get 2 square times 5 square times 7, because all the powers must be divisible by 2 as the whole value is a perfect square. Alright, so how to get the value of k? We compare the 140 and 140k here. So for 2 square, 140 is already 2 square, then the k, there is no 2 square. We get straight away 2 square here. So 5, the next number is 5, right? There's only 1 5 here, power 1. So we need to include 1 5 here in k to get 5 square. Similarly, for 7 times 7, we get 7 square. So the k is 5 times 7, and the answer is 35. For C, we know 300 equals 2 square times 3 times 5 square. Multiplied by n is 300n is 2 cube times 3 cube times 5 cube, because all powers must be divisible by 3, as we want the whole thing, when we cube root it, we get an integer. Therefore, right, the n must have a 2 here, so that 2 square times 2, we get 2 cube. Must be a 3 square, because 3 times 3 square, we get 3 cube. Must have a 5, because 5 square times 5, we get 5 cube. Hence, the n will be equals 90. Alright, you can try another example yourself. So this is an example. Given that a equals 2 to the power 5 times 3 to the power 4 times 5 square, and b equals 2 square times 5 cube times 7. Find the LCM of a and b, the smallest positive integer k, such that 3a over k is a perfect cube. C, the value of square root of 7ab over 10. You can pause the video and try to solve it yourself. Alright, so here's the solution. To find the LCM for a, right, we know that a equals 2 to the power 5 times 3 to the power 4 times 5 square, and b equals 2 square times 5 cube times 7. So the LCM will be 2 to the power 5 times 3 to the power 4 times 5 cube times 7, which gives us 2,268,000. For b, we know that 3a, right, equals 3 times, the a is 2 power 5 times 3 to the power 4 times 5 square. Then we need to simplify. So 3 repeats 1 time. So the answer will be 2 to the power 5 times 3 to the power 5 times 5a. And then 3a divided by k, we get 3a over k. 3a over k must be 2 cube times 3 cube, because all the powers must be divisible by 3, as it must be a perfect cube. So what will be the value of k? Right, this is a division, then we need to do the minus. So 2 power 5, so k must be 2 square, so that when divide, the power is a minus, so 5 minus 2, we get 2 cube. Similarly for 3, 3a is 3 to the power 5, so the k must be 3 square, so that 5 minus 2, we get 3 cube. For 5 square, since the power of the 5 is less than 3, right? So the k must be 5 square, so that it can cancel out with a 5 square, and we don't have any 5 over here, right? So the value of k will be 2 square times 3 square times 5 square, which gives us 900. For C, so square root of 7ab over 10, we need to substitute the value first, right? So which is square root of 7 times, the a is 2 to the power 5 times 3 to the power 4 times 5 square. then times the b, which is 2 squared times 5 cubed times 7, and the 10 is 2 times 5. So divide by 2 times 5. Now we want to simplify, right? If there is any body repeats, right, we can add the powers. Then for this case, right, the 2 to the power 5 and 2 square here, the 2 is repeated. So 5 plus 2, it is power 7. Alright, then the 3 to the power 4, there's only one body here. No repetition for the 3. We just copy down 3 to the power 4. For 5, right, here we have 5 square. So times 5 cubed. So 2 plus 3, we get 5 to the power 5. For 7, here's 1 7 and here's another 7. Both are power 1. So 1 plus 1 equals 2 here. So 7 squared. Then over 2 times 5. Just copy down. Then now we want to take care of the division here. We need to minus the power where the bodies divide. So what does it mean? It means that here the 2, right, with this 2 to power 7 divided by 2. So at the bottom this is power 1. Then 7 minus 1 we get 2 to the power 6. So then for the 5 here, so 5 power 1, right, so on the top is 5 to the power 5. 5 minus 1 we get 5 to the power 4. The body 3 and 7, we don't do anything, we just copy down. Alright, now the next step, we want to square root the whole thing, right, which we need to divide the powers by 2 when we square root. Therefore, 2 power 6, we get 2 cubed because 6 divided by 2, we get 3. 3 to the power 4, we get 3 squared because 4 divided by 2, right, we get 2 here. So 5 to the power 4, 4 divided by 2, we get 2 here. Next, 7 squared. 2 here divided by 2, we get 7 to the power 1. Okay, so the answer will be 2 cubed times 3 squared times 5 squared times 7. And the value will be 12,600. Alright, that's all for this video. Thanks for watching. Do you have any questions or thoughts to share? Feel free to write it down in the comment. I would love to hear from you. Do you like this video? Please don't forget to like it and share it with your friends. Until then, I will see you in the next video. Have a great day ahead.